Welcome back, fourth grade engineers. We're back in Ergstown, and today we're doing lesson 2.4, activity 2, gathering evidence in the sim. So in our last lesson, we were provided with two solutions by the city engineer. The first one was to ask people to use their devices differently or to not use their devices. And we decided that one solution did not meet our criteria because part of the criteria was that we couldn't make people change how they use their devices. So we knew that one wouldn't work. So we decided to go with option 2, which is replacing old streetlights with new LED streetlights. So now we want to find out if replacing the old streetlights with LED streetlights would save us energy. So we need to test it. But we can't go out and replace real streetlights just to test it out. I think we might get in trouble if we go and try to replace some streetlights. So what do we have to do? We have to use our simulation. We're going to gather some evidence in our sim. We are going to go to our sim and we're going to look for a light bulb and an LED light. We're going to use it to find out which device from these two uses less energy to produce the same amount of light. To do this, we're going to test the system using the following. Fuel as the source of energy, an engine, a generator, and a light bulb. And we are going to set our energy slider all the way to 100. Then we're going to run it. Remember, to run, we press the orange run button. And if you look at it carefully, we see, what do you see here? We see that the fuel's going into the engine is going to the generator, and the generator's hooked up to our light bulb. And we see that different devices transfer out different forms of energy. So our engine receives potential energy and gives kinetic. The kinetic energy goes into our generator, which turns it to electrical energy. Our electrical energy turns it into light. It also produces different amounts of energy. So we use this to figure out exactly how much is being transferred out. So our light, we can see that it is transferring out light energy and thermal energy. So we need to figure out how much of each. To do that, we're going to analyze this system. So to analyze, remember, we push this analyze button. All right. So what do you think? What do you think? If you thought that the light bulb gave us light energy, well, you're correct. But if you also notice that our light bulb gave something else, what did it give us? It gave us thermal energy. Yes, that is correct. But how much of each? If we go here, we can see that the energy brought in from our fuel was 100, because remember, we slid it all the way to the top. All right, but let's see how much came out. So in our test, the light energy transferred out was a 10, and the thermal energy transferred out was a 90. Those little red squiggles coming out of our light bulb, those showed us the thermal energy. And we didn't see any blue lights because no sound energy was transferred out. So if you think about that, we only got a little light from our light bulb, but we got a lot of heat. Remember, if you've ever turned on a light bulb and you accidentally touched it, it's really hot, isn't it? What form of energy output do you want from our light bulb? What do we want to get? If you say light, you're right, because when I turn on my light switch, I expect to get light. Do I expect to get heat? Probably not. It's more important for me to get light when I turn on my light switch. What forms of energy did we get? Well, if we look at our graph here, we got 10 for light. That's not very much, is it? but I got 90 for heat. These little red squiggles meant heat, thermal energy. When I turned on my light switch, I was not expecting to get to get any heat from my light bulb. But if you've ever accidentally touched a light bulb that has been on, you know that they get really hot. So we want to find a more efficient device. So a device that is more efficient can use less input energy to produce the same amount of the energy output form you want. So what does that mean? That means some electrical devices are made to use less energy than others. Our example is, I have an energy efficient radio, and would it use the same amount of energy to make the same amount of sound, or would it use less energy to make the same amount of sound? So what I'm saying to you is if something is energy efficient, it uses less energy. So an energy efficient radio uses less electricity to make the same amount of sound as a regular radio would. So let's go to our investigation notebook, and I want you to turn to pages 33 and 34. It's called Gathering Evidence in the Sim. We're going to read the directions together. The first two systems both use energy from the sun, as you can see here. Sun, sun, right? They are the same except for the devices. If I look at my first one here, one has a light bulb and one has an LED. The third and the fourth systems both use energy from the wind. See my wind here, my wind here. They are also the same except for the devices. We have a light bulb in one and we have an LED in the other. Your job, or our goal, is to get at least 10 units of light. So we're trying to get the same amount as when we did our first demonstration, transferred out of every system you create. That's your goal. So you have to figure out how much input energy is required to make the LED produce the same amount of light energy as a light bulb. So you're going to have to try a few different ones. You're going to have to run different systems to get the amounts correct. So I expect you to try a few. We're going to do this in the sim, so let's review. How do we get there? You're going to go to your SHS bookmarks, and you're going to look for Amplify Science. Once you choose that, you're going to go to the picture of Ergstown that we look at all the time, which is energy conversions, and then you're going to choose the orange box that has the 1 in it. You're going to use the sim to test how much energy it takes for the LED to put out about the same. We want it to be 10, so let's go exactly the same light energy as a light bulb. And you're going to record your results. You're going to tell me the light, the amount of light energy, the amount of thermal energy, and the amount of sound energy that is being transferred out in every single system that you run. And then we'll talk about it in the next video.